Welcome to Biostatistics for Non-Statisticians. We would like to explain the CONSORT extension to equivalence studies, where the objective is not to demonstrate that one treatment is superior to another, but to establish that they are reasonably similar. Let us begin. The usual statistical approach uses the alternative hypothesis to determine what you want to end up establishing. For example, researchers may want to find out if there is a dose-response relationship, or whether or not the new treatment outperforms the classic intervention by a delta amount. This construction is suitable for difference testing. However, when we want to demonstrate equivalence, we put in the alternative hypothesis what we want to demonstrate, absolute equality, as well as some minor differences, that we will also consider as equivalent. Remember, equivalence is broader than equality. To see why the difference test is not adequate, it is enough to remember that the absence of proof is not the proof of absence. This plot shows the greater breadth of the equivalence concept. For example, we will consider the null hypothesis to include two symmetric scenarios. Neither treatment outperforms the other by more than, say, 10 mmHg. This value of 10 mmHg is a value previously established as clinically irrelevant. If we can reject one of these two hypotheses, we'll have shown that one treatment does not beat the other by more than 10 mmHg. So, for example, rejecting one hypothesis indicates non-inferiority, and rejecting the symmetrical one indicates non-superiority. If we can reject both null hypotheses, we'll have shown no treatment outperforms the other by more than 10 mmHg. So the intersection of these two hypotheses leads to establishing equivalence. If we can demonstrate both non-inferiority and non-superiority, we have demonstrated equivalence. This leads us to defining the two-sided test, in which we perform two unilateral tests in order to reject each limit of equivalence. If both are rejected, we have been able to establish equivalence. Thus, the great novelty is this margin of non-inferiority, the clinically irrelevant difference. Of course, this margin must be less than the size of the relevant difference, which is the delta effect established in the alternative hypothesis of the traditional test. In this example, first, we define a symmetric margin of equivalence of 10 mmHg. If either hypotensive drug lowers blood pressure by 10 mmHg more than the other, both products are not equivalent. Second, if we have the results of a paired study in which both drugs have been applied to 20 patients, it has provided the results of an outcome difference with a mean of 3 and a standard deviation of 10. Third, both tests reject the null hypothesis, with p-values of 1 and 3 per thousand. Thus, this study has shown equivalence. And what do we do now, after the p-value crisis? Well, the same as before. Use the confidence intervals, which are easier to interpret. In the example above, the interval ranged from -0.866 in favour of one drug to 6.866 in favour of the other. Since the full 90% CI is included within the limits of equivalence, we arrive at the same conclusion. With what confidence should we make the interval? As always, take a good look at the corresponding guideline, either for reporting or for regulatory issues, and follow it faithfully. The study size calculation is similar to the classical one. Although two subtle differences in the denominator lead to a larger sample. First, a smaller epsilon of a relevant difference replaces the delta of relevant difference. And second, even recognizing that the strict equality was not real, we may still want to establish equivalence. Let's also say that in an equivalence study, we must monitor the sensitivity of the study, its ability to demonstrate differences, if they exist. 'Tis always a good idea to replicate every detail from a previous clinical trial that showed differences. In summary, CONSORT's extension to equivalence and non-inferiority studies requires specifying 1. Equivalence or non-inferiority in the title, 2. The non-inferiority margin, 3. The adaptive sample size rationale, and 4. Either the confidence of the interval or the alpha risk for the test. And that's all for today. Well, no. One final tip. Practice. As a team, check whether or not an article that you find interesting follows the recommendations of the CONSORT extension to equivalence or non-inferiority studies.